Alright, L'Hopital's rule is a very easy rule to use, and it mainly comes out when you have like 0 over 0 or infinity over infinity, any of the indeterminate forms. Um, so here's a really good example. So if you were to evaluate this at 0, sine of 0 is 0, and 0 is 0, so you have 0 over 0. So if you end up with that indeterminate form, you don't know if it's 0 or if it's infinity. All you got to do is look at the rate of how fast the numerator goes to 0 over how fast the denominator goes to 0. So basically, you're just looking at the derivative of the top divided by the derivative of the bottom. So we just take the derivative of the top, cosine of x, over just 1, and now we're going to plug in our 0 and see what that ratio goes to. Cosine of 0 is just 1, so 1 over 1 is 1, and that's it. Same thing over here. If I plug in 0, I end up with 1 minus, 1 over 0. So you do the derivative of the top, which is sine of x, over 1, and now we plug in our 0. Sine of 0 is 0, and so we've got it. That's mainly what L'Hopital is. You take the derivative of the top, derivative of the bottom, not needing the quotient rule, because we're really looking at the rate at which the top changes with respect to the rate at which the denominator changes. Hard thing about L'Hopital's rule, at least in the way that our book deals with it, is it deals with all sorts of craziness. So these are all the different indeterminate forms, and every one of them you can use some sort of L'Hopital's rule. So if it's 0 over 0 or infinity over infinity, that's the main two forms. It's when you get something like this, where you have 2 to the negative 1 over 0 raised to the 0. Basically, you end up with, well, let's think what happens here. This is, you can rewrite this as 1 over 2 to the 1 over x raised to the x. So we end up getting, well, as far as the algebra goes, something raised to a power, you can really just multiply them. So we have 1 to the x over, which is 1, just 2. So that one's a little silly. But if you try to plug in the 0 directly, 1 over 0 from the right ends up being infinity. So you got 1 over 2 to the infinity raised to, well, to the 0. So we have a 0 raised to the 0, which is this indeterminate form, which means I could use L'Hopital's rule. But rules of powers allow me to multiply. So we end up with our 1/2 anyway. But this is an indeterminate form if you try to do it directly. Same thing here is if you try to plug this in directly, you end up with, well, infinity times e to the negative infinity, which I know you can't plug directly in infinity, but if you were to, you get infinity times, well, 0, e to the negative infinity. That ends up being infinity times 1 over e to the infinity, which is 0. That's it's indeterminate form where you get 0 times infinity. So the question is it 0 or is it infinity? Well, it all depends on how fast they go. So if you rewrite this as x over e to the x, now all of a sudden you get infinity over infinity, which is this form right here. Now we take L'Hopital's rule, which gives us 1 over e to the x. And if we plug in infinity now, we end up with 0. So it really depends on which one goes to 0 fastest. If the numerator goes to 0 fastest, we'll go to 0. If the numerator goes to infinity fastest, we'll go to infinity. If the denominator goes to infinity fastest, then we'll end up with 0, like in this case.